And we are live. What is up, everybody? Welcome to the Data on Kubernetes community live stream number 147. Always got to be careful what number we're on. Don't want to go too far ahead. But let's be honest, we've done a lot of content, been creating a lot of stuff. And as usual, want to update you about things we got going on in the community. If you have not checked out our CFP, do so quickly because time is ticking. You've got a few hours left to get your CFPs in for Data on Kubernetes Day, which will be on October 24th. If you have not registered for that already, first of all, why not? Come on, register. It's super easy to do. It's free. Just got to add it to your KubeCon schedule. Like I said, it's going to be on Monday, October 24th. It will be hybrid. We'll be on the ground in Detroit. I was just talking to today's speaker about sort of our KubeCon plans. And we will also be doing it virtually. So you can submit talks that are pre-recorded, that are given virtually, or that are given in person. We've got all the guidelines there in the CFP. And like I said, registration couldn't be easier. Other things that we've got going on in the community, always a good thing to check out as we're with one of our lovely members, community sponsors today, is our landscape, right? So the DoK landscape, you get a chance to see as end users all the different technologies that are listed there. So you can make the decisions that you want to make on which one is going to be best for your use case, which one is going to be best for your organization. So always check that out. Like I said, lots of good things there. Without further ado, today's speaker is going to be talking about the storage landscape. His name is Dinesh, CTO at Civo, awesome company. How are you doing today?
Yeah, very good, very good. It's the heat wave here in the UK has kind of ended, and I'm very glad about it, and my garden is very glad about it. And I now feel incredibly stereotypically British because I've said hi and spoken about the weather. So, you know exactly where in the world I'm from.
I have to ask, what's in your garden? What's in your garden, though?
So we've got a lawn that is dead but is coming back. But sort of every year I start planting some plants that either I kill or survive by pure luck and chance. And this year we've got some lovely roses that have survived by pure luck and chance.
Okay, so there are some upsides to some of the things we're experiencing regarding climate, but like you said, I've been having some crazy weather all over the place. That being said, Dinesh, you gave a talk about this topic already, but just to give folks some background, your experience with storage, and then on top of the Kubernetes world, maybe just a quick summary of the talk that you gave in the last DoK day before we jump into today's.
Absolutely. So actually, this is, I think, turning into a little bit of a series because this is now the third on the same sort of project that we are talking about. So we had an opportunity to kind of evaluate all of the storage projects that were out there because we were moving from one vendor to another. Or shall I say we had the option of moving from one vendor to another. So we build a cloud platform and it is built from the ground up on Kubernetes, and storage plays a huge part in that. So when we started this project, probably about 2.5-3 years ago now, we went to market, evaluated what was available and went in one direction. And then sort of 2 years down the line with that, we had an opportunity again to reevaluate it. So the talk I gave at DoK days before KubeCon EU was almost like a lightning talk about how you would kind of go about choosing vendors, evaluating products, and doing your own little mini benchmark.
For folks that don't know Civo perhaps and how you got into this, could we just get a little bit of background on that?
Yeah, so Civo is a public cloud similar to the likes of DigitalOcean and Linode, Amazon. What our aim is to provide a really easy to use Kubernetes cluster for you as a customer. So we provide those virtualized Kubernetes clusters on top of hardware that we own. We put in a data center, and then you can kind of click a button on our website and you get a Kubernetes cluster that's fully compliant, off for you to use in a public cloud. I think our mantra at the moment is cheaper, faster, easier than some of the other vendors out there. The project, for me at least, is about 2.5 years old that I've been involved in Civo. Moving from an OpenStack environment to something that we've built from the ground up. So there's a lot of blood, sweat, and tears in the Civo project that we've put in, but it's a really enjoyable project. And I think I said to some of the staff, actually, I feel like it's some of the best work I will do in my life, which is absolutely crazy to kind of think that I can look back at either the last 2 years or the next few years and think, I've really got to enjoy this.
That's great. With that being said, all that passion, all that excitement, if you want to share your screen, go for it. And folks, remember, if you got questions, please put them in the chat. And as always, we can continue the conversation on Slack. So take it away. The screen looks good.
Absolutely, yeah. So if there are questions, please just ask them. Bart, interrupt me. I think that's the standard way we've done these in the past. So don't feel shy. Just jump in, and I'll happily take questions as we go through. So a little bit about me. I feel these slides you kind of have to stick in, but it's weird talking about yourself. I've been doing this thing for 15 years now. I've got a developer background, systems architect, been doing DevOps engineering kind of as that movement has come across. And as I mentioned earlier, I've been the lead architect of the new platform that we've deployed out at Civo that we call Civo Stack. Civo, cloud native service provider, which means that we are building a public cloud for everyone to use, which is based on the CNCF landscape from the ground up, which means that we're using Kubernetes to do all of our control plane, that we then build VMs to give people Kubernetes on top. I think recently one of the engineers then put Kubernetes on top of that. So it really feels like turtles all the way down, that you're putting Kubernetes on top of Kubernetes on top of Kubernetes with a never ending kind of spiral. Kind of on the data side, which I know is what people here are kind of most interested in, is currently we've got over 300 terabytes of end user data stored in what we call our superclusters. And we've got those in New York, Frankfurt, and London at the moment. Is kind of where our physical points of presence are. So project that we started off, as I said, 3 years ago. We went out to market as it was then. And I have to say, it was a pretty young market. There weren't a huge number of choices out there, especially for what we wanted to do, which was provide a pretty cheap service. Going to some vendors like your Dells and your NetApps, the price of storage was really, really high, and we needed something that had a really low cost point. So we went with Storage OS, Ondat now, and we put in an agreement, a commercial agreement that lasted I think it was a year and a half, maybe 2 years. And then this kind of came to the natural end of that. And, as with all renewals, the price went up a little bit. We had some outages at the time. They weren't really of big note, but it kind of just, when the renewal comes up, you're having issues, you take the opportunity to review what was out there. So that was the process that we kind of went through. And we actually ended up moving. So I've got some logos there: Rook, Ondat, OpenEBS, Longhorn. Those are the projects that we evaluated. And out of that, we went with Mayastor, which I really realized doesn't have a logo, but is part of the OpenEBS umbrella. I just want to heavily caveat that everything that I'm going to say with opinions at the moment is based on where all of these projects were in summer 2021, which is now over a year ago. And I know that all of the projects have moved along. So some of these opinions, some of these thoughts, some of these notes on the projects are a year out of date, just because that's when kind of our choice was made. I will definitely caveat that again, because what I don't want people to do is take what I say about these projects now as where they are. I know in a year, a lot of these projects move on a long way. And I know one of the reasons we chose not to go with Longhorn has been resolved now, and it would be evaluated differently. So similar to what we were looking for when we first made the storage choice, was we were looking for a partnership. We are building a relatively new product. We're very quickly turning out new features. So we're looking for a partnership. And that was really, really key for us when we went to market and when we went to talk to all of these vendors, is we understand that things go wrong, that features aren't there that we need day one or that we would like day one. But we want to be able to grow both the storage product that we choose and for the storage product we choose to help us grow. And that was really, really key for us. The other thing is we're our customer base is changing. So we were really key to get someone that had enterprise support, not so that we could point the finger, but we had that backup so that when things go wrong, we were able to talk to people that know storage inside out and could help us and guide us along the way. That's also not to say that we wanted not to contribute to that, which is where that next point about it being open source was really, really key. We've got a lot of developers, we've got a lot of expertise in-house, and the ability for us to be able to look into the code, get an idea of where something is going wrong was really, really important to us. I think actually that came to fruition with Mayastor almost within the first month or 2 months of us deploying out. So at the time, Mayastor was in beta when we chose it, and they were working towards a 1.0 release that I think came December, January of this year. And one of the things that they hadn't been able to test was the scale that we were running at. So that 300 terabytes of raw data is spread across something like 2.5, maybe coming up to 3,000 PVCs. And that's what we found is it's not a scale that a lot of these projects work at. We found that these projects are normally deployed onto a relatively small cluster of up to 20, maybe 40 nodes, and the number of volumes are quite low, or the amount of space is quite low. So when we started pushing the boundaries of what Mayastor could do, we found that we started seeing some timeouts. And actually, with the project being open source, we could immediately start going in, seeing that there was an option to increase the control plane timeout, the amount of time it would take to query the state of a volume, from a default of, I think it was like 5 seconds. And for our use case, we were like, right, just push it up to 30 seconds. We know we're going to not get into trouble with that. And we were able to do that by looking at the code, realizing where the problem was. And then we actually gathered the data, worked with Datacore at the time, Datacore now, Maya Data, I think it was at the time, to work out why we were seeing these slow requests. And then we got a fix, worked with them into the product, which means we could lower that timeout back down. So it was really, really key that something open source where we could poke, prod, maybe cause ourselves our own problems was really, really key for us. The next thing was the underlying technology. My background has been in sort of hosting for a long time, and I've used Dell, I've used NetApp, I've used HP, I've used a huge number of SANs, and they're all basically the same. They've got some nice funky GUIs on top, some different things here and there, but they call things the same, or they call things differently, but it's the same technology under the stack. What was really nice about Mayastor was that they were using NVMe over TCP for the data transport, which the industry, I think, as a storage industry, we're moving towards anyway, because it provides just a better way of communicating with network attached storage. And actually Mayastor being on that already was really, really key for us. And we can see the potential for the project to grow and to keep getting better. Surprisingly, I've put the bottom two down at the bottom, performance, scalability, durability at the bottom, because to a certain extent, they're not particularly important to us. Yes, we do need it. Yes, it's a requirement. But if a storage product doesn't have those, they're not really a storage product, so we wouldn't be considering them. So the stuff at the top of the list is kind of an order of where we were looking at, and performance, scalability, durability of data should be a given, at least at this stage of a storage product's life. What I want to drill in today is to talk about performance testing and kind of drill into that one. I know I said it wasn't important to us, but I know for a lot of people, it is important because it's a number, and you can go to vendor A and go, oh, look, my number is this, but I tested your product and my number is that. So it's just a bit of, it's some stuff that gets thrown around a lot. And I wanted to give everyone a bit of background into how we looked at performance and some of the tools that we used. So DD is a command on Linux, which is pretty commonly used now or was used to test disk performance. And it's a low-level tool to basically take data from one source and write it to another source, and you get a number out of the end of it. It's generally a sequential process of either reading or writing. And we found that actually it doesn't give us very representative real-world results. The reason for that is that there aren't very many real-world use cases that do a direct read of a load of sequential data or a direct write of sequential data. Just thinking of something off the top of my head, it's probably something like metric store or log storage that would be doing that sequential read or sequential write. But something like a database is random read, random write. If you're doing a sort of web request or you're doing web hosting and you're pushing out images, again, that's a lot of random read of data across a disk. So the next tool down there is FIO, which gives you a lot of knobs to tweak and a lot of options and a lot of output, and is really, really tunable to kind of replicate what your use case is, what your real world usage is, and then get some representative results. What I'm going to do today is a demo, and I'll quickly do DD, kind of show you what it gives out, and then go through FIO and give you some examples of how to use it. So what I've got up on as a demo environment, I've got a Kubernetes cluster made of 3 control planes and then the compute nodes there. These are all virtual machines that are running in one of our production regions, and I've thrown together Flannel, Mayastor, with a couple of storage classes as well on there. What I want to do today is show you the performance on the compute nodes talking directly to disk, and then show you an example of how you test that with Kubernetes and putting a CSI driver or a storage vendor in the way. What you're really looking for when you do this testing is a comparison. So your raw disk access, talking directly down to dev SDA here, gives you an idea of what your maximum throughput is. And then you're comparing the other vendors or the other storage providers to see what overheads that they put in. And it's not a case of, oh, you've lost 80% performance or 50% performance. It's a case of, is that overhead acceptable for your use case? Because if you need 20 replicas of data, there is an overhead with that. And whatever that level is depends on what your acceptance of the, whatever your acceptance of that is, changes whether or not something is performant in your eyes. With FIO, there are, as I said, lots and lots of options. These are some of the things that I want to demo today. The first one there is really, really key for doing demos like this, is that I'm doing 10-second runs of all of these tests, and you can use that with the time-based and the runtime. We could sit here for minutes and minutes and minutes at a time as I change all of these parameters, but I mean, it would be a very long talk and not very interesting. So I've kind of ramped that down to 10 seconds just so we can get through a couple of tests. I then want to show the impact of block size. So whether you're reading and writing 4K blocks or 64K blocks gives a big variance in the performance numbers that you get out. And then same whether you're doing read, write, random write, or you're doing both at the same time, will impact the numbers that you get. Once we've gone through DD and FIO on the compute nodes and talking directly to disk, I just want to go through Kbench, which is a tool that we found that wraps FIO into a Docker container and a Kubernetes job that just makes it easy for us to run some tests. But all of the tests that you can do directly on a compute node or a Linux machine can be taken and put into Kbench. I won't show that in detail today. It'll just be a quick demo. But if you create a config file for FIO and use that on your compute nodes, you can mount that as a config map or as a volume and use that in Kbench as well to give you the same tests that you can do comparative analysis for. I guess before I jump over to a terminal, Bart, any questions yet?
I definitely love the because I mean, let's face it, like this is one of the things that comes up in different talks. People have different schools of thought on this, but some will say, pre-record your demo so you can just narrate over it and you know for sure that it's going to work. What are your thoughts on that?
I don't know. I love living dangerously. I love a live demo. I feel that, I'd actually say live demos going wrong gives a real opportunity for someone to learn and for the audience to kind of see the process of, oh, it's gone wrong. This is what we're going to check. This is what we're going to do to diagnose the problem. So hopefully nothing goes wrong and my diagnosis skills don't be put under pressure. But it's always an opportunity.
Good. Let's do it. Let's dive in.
Right. Hopefully we've now got a terminal. Is that big enough for everyone to see, or should we just go up another screen size?
Maybe one more screen size just in case. But folks, if you have any difficulties seeing it, just let us know in the comments.
Cool. So what I've got at the top here is an SSH connection to one of the compute nodes. Down at the bottom, I've got my local machine and some little cheat sheets of what I'm going to be running. So the first command that I'm going to run is that dd command here. So we have got an input file of dev0, which is just always printing out zeros. An output file of /volume/test, which is just a file on the root disk. We're going to be writing 10 gig, and we're going to be around one of those. With DD, again, as I mentioned, with 4K and 64K, there's different ways of providing that, but this is a easy way of providing a 10 gig file. You've got these options of flags as well. One thing that you need to be really careful of when you're doing storage testing and performance testing is that Linux by default will use memory as a cache for both reads and for writes, which means that you need to understand the commands that you're running and the tools that you're using to make sure that you are testing the disk or the system that you intend to be testing. And Linux isn't doing its really, really clever things of giving you better performance through the way. For memory, this will go directly to disk. And I'm sure there are other flags that I can use to get better results. But for the case of this demo, this should be going directly to disk and writing a 10 gig file. Now, hopefully it takes about, 6 seconds to write. And it's got with a throughput of 341 units. I really want to be vague on this because this testing really depends on what you're running, what hardware you're running, what CPU you're running. So the actual numbers don't really matter. It's the tools that you're using and the tools that I'm going to be showing off here. One of the other key things when you're doing any sorts of this testing is run your commands multiple times. Because as you can see here, this box is doing nothing other than a basic Kubernetes install, which I say isn't doing anything, but it's doing very, very little. It's not got real world workload on it. And you can see that there's a variation here on the amount of time it takes to write that same 10 gig file. So you need to be running these multiple times. If you're working with a cloud provider or on a cloud provider, try and test at the times that you know that your workload is busy. So if you've got a batch job that you know is really read-write intensive that runs overnight, you really want to be trying to do your tests during that time period because you then know what the cloud provider might be doing around that same time. There was one issue I had, not with cloud providers, but when someone was doing backup jobs overnight and saw a kind of a flat line in performance, and it's just sort of one of those things that you needed to then debug at the time and work out what else was happening on the network and try and debug what was going on with that difference in performance at that time. So run things multiple times and try and run things at the same time that your busy workload is going to be. Other things that you can do with DD, this is a write test because we're writing the output file into here. If you swap these around, you can do some read tests and things. But as I said, this is a sequential read or a sequential write and isn't overly useful unless you want to throw some numbers at a vendor and say, hey, look, your stats are bad, which definitely does happen. So moving on to FIO, we're just using that same file. We're going to be doing 10 gig again. We're doing 4K blocks and we're doing a sequential write. So push this down again with that 10-second runtime. So hopefully we get a number that is similar enough to 350. So bandwidth there, depending on which number I want to read. Look, 320. That's definitely close enough. But breaking this down, there's a lot of data that you get with FIO, and you can start drilling into this if you start knowing your own use case of, is IOPS really important or is it raw throughput? So it's almost like an exercise to the reader of analyze your own workload and then find the right commands and the right output that's important to you for when you're tuning FIO. So we'll run that again, and hopefully we get a figure again similar to that. I'll use this bandwidth figure here, the 305 megabytes or megabits per second. I can't remember which way around that is. But again, units are important here when you're doing testing and when you're doing comparisons, in particular between different tools. Make sure you don't get caught out by that. So 310, 305, I think that's pretty similar. The next thing that I wanted to show was on that byte size. So if your application is able to read and write in bigger blocks, you need to be tuning FIO to represent that. So just by changing that one block size from 4K to 64K, we've now got a number here of 512 meg, 488 megabits per second. Again, now, if you were putting these numbers in a report or something, which do you use? Which is right? Do you say that storage vendor here should be trying to hit 488, or should they be looking to hit 310? Depends on your use case. Again, I'm going to say that over and over again. So yeah, just be really, really careful. Example here of changing this now into a read. Because we're using the same file, FIO will note that the file is there and now start doing a readout, and we're getting 3 gig, 3.7 gig out, which is pretty nice out of a read. And again, that was sequential. However, we can quickly change that into a random read. So this is potentially more representative of what you could be seeing in the real world. What's nice here is it doesn't seem to be a huge difference. I don't think you really see a big difference between random reads and sequential reads, especially on the systems that we're running on today that they've got NVMe drives under the hood. We might see a difference on writes. Let's just see. So it's 400 odd, and coming back up here on the sequential write. See 488, 512, a little bit slower. So yeah, if you're chasing top end performance, be tuning your workload. There are other things that we can test. You can change this into I think RW. This will now do reads and writes at the same time. So we're getting a figure here for read throughput and write throughput. As you'd expect, it is slightly lower than your potentially half, is it? Depending on your hardware and depending on everything that you'll get. But you do expect lower performance when you're reading and writing from a disk at the same time. So hopefully we come up to this shell here. So what I've got here is a Kubernetes view of that same hardware. So control plane, oh sorry, compute 03 blah 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 013 is that compute node here. So I've got in here a PVC that I can provision. Oh, sorry, I should say I've got some storage classes that are listed here that are backed by Mayastor. So this one here is one copy of the data. This one is one copy of the data, but is set up so that the pod must be on the same node that the volume is hosted, whereas this one would allow for remote mounting. Not guaranteeing it, but allowing for it. This one is two copies of the data. This one allows for remote mount, and this insists that the pod must be scheduled on one of the compute nodes that has a copy of the data. And again, it's really important to understand these nuances when you're doing your own testing of what is allowed to happen, what is running, and where is it running when you do your tests, to say that, oh, hang on a minute, if my volume is remotely mounted with two copies, so it's now requiring bandwidth to two remote compute nodes, what impact does that have? And then you need to ask yourself, do you expect that to happen in your use case? Yes, no, or do you want to rely on a local mount? And then what performance do you get out of that? So we're just for this one, just going to be using for the first test, a single copy of the data that must be locally mounted, because that's very similar to what we were doing up here with DD, which is effectively single copy, sorry, FIO up here, not DD, single copy, and it was being read and written locally. So we'll create that PVC. That already exists. That's fine. Let's delete it. And see, live demos, they always get you. So we'll create that. So we've now got a 20 gig PVC that has one copy that must be locally mounted. I'm just going to create the job now. And then I'll run through what the job is doing. So we're taking that persistent volume, we're mounting it, making it available in /volume, and then we are using this Kbench image, which is a wrapper around FIO, to do a 10 gig test against a similar named file. And just for the purposes of this demo, I've turned quick mode on. I'd recommend looking at the environment variables for the project. There's a link to it in the slides to dig into more detail of what these environment variables mean. So we've got that pod running. So this takes a little while to run. I wasn't able to speed this up, but this is going through and it's running a couple of predefined benchmark tools, FIO options. So this is doing a quick IOPS test against that 10 gig file. I guess while this is running, Bart, any questions from the viewers?
One thing that frequently comes up with storage is it seems often, and I don't want to offend anybody in the audience who's a hardcore storage fan, but it seems like a tough thing to make it sparkly and sexy. Would you agree or not agree, and why?
Sexy is an odd thing because
that's very subjective. Let's say
it's a very
exciting, thrilling and exciting.
Thrilling and exciting. I'd kind of agree. It's a very old market when you kind of go back into what storage is. Yes, the wrappers that cloud native providers are putting on them is more exciting and more new, but as a technology, it's really quite old. You're putting blocks onto a disk and you're reading blocks off a disk and making them available either locally or remotely. Everything else on top of that is just sugar to a certain extent. But saying that, when I was doing this analysis, learning about NVMe over TCP was actually genuinely exciting, and something that I was excited to see, a sort of a new technology coming out. So a very quick primer on what NVMe over TCP is. So probably not this audience, but a lot of people know NVMe as a storage technology for hard disks or for flash drives, but it's actually a protocol for accessing blocks on a device. What generally we see is kind of, it's not called it, but NVMe over a PCIe bus, which is local access to the blocks. NVMe over TCP allows you to use TCP, so Transmission Control Protocol, to send NVMe commands to a remote device, or basically over a network, and then get the data back in an NVMe kind of packet that comes back. So there's like a control flow and then a data flow, and it's exposed over a network. And then there's like NVMe over fiber channel. So again, if you're in the storage world, you know about fiber channel, and that you can do NVMe over fiber channel as well. So that's a really interesting piece of technology that's coming out. Intel, I know, have been pushing that a lot recently. And I genuinely feel that it's going to be replacing iSCSI in the storage world. So if you buy a SAN, rather than in the cloud world, if you ever go out and physically buy a SAN, you're going to be seeing NVMe being the way of accessing it rather than iSCSI. Cool. So that kind of answered it.
No, that's good. I mean, like I said, this could probably take days to fully address it. I think one of the things is that certainly adds an element of thrill is the risk if things go wrong with storage. And as you started out, if you have an outage, what kind of issues are going to be facing, whether we want to call that exciting or certainly can be preoccupying. I think that does add an interesting element to storage. But anyway, great answer.
Yeah, I definitely say outages is not the sexiest thing about storage. No. It's sort of one of the things that you've just got to deal with. Cool. So this Kbench tool, it spits out what looks like different data, or it's differently formatted data. But you've got here now in kilobits rather than megabits for random read, random write, sequential read, sequential write. So it covers a lot of the tests that we did up here with manual FIO runs into kind of combining it all through. And then I know that there's a bash script that reads the output and presents back only these headline figures that we get here and that we were looking at with FIO. It prints it out here into a pretty summary. But this is a way of doing it. I'm just noticing the time. We've not got a huge amount of time. So what I was going to do with this demo is change this storage class into 2 replicas and then just show you that the numbers change. Again, whether they change in a good way, a bad way, whether it's up, whether it's down, depends. So I won't do that. It's going to be the same sort of thing of deleting the PVC, recreating it, running the job again. And when I said with DD, still applies here. You want to be running these benchmarks over and over and over again to get some averages. Well, thank you, demo gods, because I think that went okay. Apart from some cleanup from my testing, I don't think much went wrong. What I've got here, I've just dumped out some of the commands that I was using so that if you do come back to this and you want to view the slides, you should hopefully be able to copy and paste these out as at least a starting point. So there's the DD command. We've got the FIO command that I started off with. I think this has got the 64K bytes in here. One of the other things that I didn't mention is this number of jobs command. You want to tie that to the number of CPUs that you've got available in your box, because the way FIO works is it tries to max out the CPU cycles and the threads that you've got in a machine, which actually is a note that you need to be careful if you're running this on a production system, because it will hammer CPUs as it does your testing. I've got the PVC definition in here, and then the job as well. Both of I think the PVC and the job are available on KBench, and as a reminder, that link to the GitHub repo is up here again, so you can grab that. I think I talked about this briefly while I was doing the demo, but there's a lot of things that influence the actual numbers that come out. The underlying hardware, whether you're using spinning disks, the speed of the spinning disks, whether you're using SSDs, NVMEs, whatever you're using. I mean, you could even use these things to test things like memory, if you're using a memory device, and you could probably test the speed of memory if that's applicable to your use case. I know that some databases now will create a RAM disk and use that for caching and things. The other thing there is CPU usage, and the CPU that you've got, especially with FIO, it tries to max out CPU usage. So just bear that in mind and try and make your test environment as similar to a real world use case that you can. So if you're running in a cloud provider and they've got multiple options and multiple flavors, I know that some providers as well give you storage optimized or RAM optimized or CPU optimized machines, and then you've got block devices as well that you can attach that have varying performance. I mean, it should be obvious, but use something that you're going to be using production workload to do your testing. The other thing there is replication. Are you, or is your driver, or is your provider doing replication, and what impact does that have? And then,
real quick, we got a comment.
Yep.
I guess the standard problem with Kubernetes storage is that you get really persistent, high latency remote storage, or local, not really persistent, low latency disk. I'll drop that here just so you can see exactly how it was written.
Yes. Again, it depends on the technology that you're using. I know that some of the projects that I've spoken about rely on iSCSI in the backend, so you're kind of reliant on how iSCSI is tuned, how the underlying kernel is tuned. If you're using ZFS, potentially for doing that storage, especially if you're trying to do distributed, then you're relying on that performance, and that's what's going up. So I wouldn't say that it's a Kubernetes problem. It is a storage problem. I'm using problem not happily that I'm using the word problem, but it's a choice of the storage solution that you are using, and that's just represented up. It's not that Kubernetes is implementing this, or that a particular CSI or storage vendor is doing it. Choices have been made with the underlying storage product to be used, and you are seeing the outcome of those choices. Does that kind of cover it? Hopefully it does.
Yep, good enough for now. And if there's any follow-up, I'll let you know.
Yep. And then the last thing, again, I've said it a lot, but try and analyze the usage performance that you expect. Is that block sizes? Is your workload 40% read, 60% write? Is it 70% write? Is it 30% read? And then tune your performance testing tools to work out what you can expect when you move your production workloads over. Before I go into kind of why we went with Mayastor, I think it's, again, really important to understand what our use case was. So it's a multi-tenant public cloud. We've got bare metal, and interestingly, when we deployed this, we had existing hardware in place that we couldn't change. So the choices that we had made 2 years ago locked us into some of the decisions and some of the kind of corners that we found ourselves in when we reevaluated the market. I think in particular, us being hyperconverged, where we have storage on the same nodes that we put compute workload on, influenced which projects we could use. And then the last note there, I think, it was 2,000 PVCs when we went to market for this, and we're now at like 3,000 PVCs and 300 terabytes of raw storage distributed globally. Not to say it is the largest, but it is on the larger end of what these projects see. And then here, some of the other things that were important to us is we have existing deployment pipelines. We use Terraform and TerraGrunt. So we needed to make sure, however we install and manage the storage infrastructure, tied in quite nicely with what we had. I think luckily a lot of these projects use Helm or Helm equivalent or customized, so that wasn't a huge issue, but just something we had to bear in mind. And then we had a metric that was really, really key to us, which isn't measuring the throughput of storage, but is the time it takes to launch a cluster, which is when a customer presses, give me a Kubernetes cluster, and then we're aiming for between 90 and 120 seconds later for that cluster to be ready. And that was actually the metric we were using to compare vendors against, is what impact did it have against that. And then, so when we presented it, it wasn't a case of, oh, storage product A gives a 500 number and this one gives a 520. It was a case of, this one changed our average launch time from 90 seconds to 120 seconds or vice versa. So it was a real world metric we were able to use. And we were also lucky enough to have a staging rack that mirrors our production rack almost exactly. So it was really nice and easy for us to put these different products on and then do a storage test for a day. The other thing in there is storage loss against raw disk access. Again, just a metric we presented. Then day 2 operations was also key that I think sometimes get missed, which is, how do you do upgrades? How do you monitor it? What is there any tracing that comes out of the product? What can we use to help get ourselves out of trouble? Or are we reliant on a storage bundle that we've got to send off that we're then waiting to hear back of, oh yes, you're seeing some timeouts, please up this setting from 20 to 30. Can we do that ourselves, or do we need to wait for that to be fed back to us? And then lastly was the commercials as well. We were really, really keen on having commercial support. So what were the prices of that? Whether or not you need commercial support will depend whether or not that is on your list of requirements. I caveated this at the start and I'm going to caveat it again. This is all of the next thoughts that I'm going to provide are, firstly, they're Civo's thoughts of where the projects were over a year ago. So I recommend that everyone goes away and does their own analysis. However, you can bear in mind what I'm about to share. But do your own analysis. So Ondat were our incumbent. They were Storage OS at the time. So we understood them well. We understood their kind of pricing model. We understood their performance. We understood their support process. So kind of, luckily this had the least amount of time we needed to spend on it because we'd had a year and a half, I guess, of using the product. The key thing here, I think, for us was that kind of the pricing structure was changing, and that's why it kind of pushed us into going to market. So the Longhorn project, I know this top one has been changed, and I caveated that, but there was, at the time we evaluated it, there needed to be a single pod for every PVC, which meant for us doubling the number of pods we were running in our cluster. So going from 2,000 to 4,000, which kind of ruled them out of the gate. We launched some test cluster, spotted this was still the case, and then moved on because running that extra number of pods just wasn't feasible. And then also to support our scale, we want to be going to 4,000, 40,000 volumes very, very quickly. As I say, if we were to reevaluate it, that has changed, so we may make a different decision, because actually we really liked that we could, we've had a lot of experience with it. It was installed inside our customer clusters. It's built by Rancher SUSE now, really works well with K3s that we had, so there were a lot of benefits, and unfortunately there was one thing against it. Rook Ceph, this was kind of evaluated more on the Ceph side than the Rook side. We had a good amount of experience with Ceph when we were previously running OpenStack. And the reasons why we didn't go down this route were that we were running hyperconverged, which Ceph generally shies against. Ceph, at least it feels like, wants a few boxes with a lot of disks rather than a lot of boxes with a few disks. But saying that, there's a huge amount of community support. It's a really, really mature product. And I know that there are some absolutely massive Ceph installs that are out there. And I think this comes back to my answer to the question about the storage options provided by Kubernetes is Rook isn't really what we were evaluating. We were evaluating Ceph, which is the underlying storage technology. Rook is a nice fancy wrapper that makes Ceph a hell of a lot easier to understand. And what the Rook project has done, I'm really, really impressed with, of making Ceph easier to use, especially in a Kubernetes environment. So for those of you that do know the OpenEBS project, there are multiple drivers, I think Jiva and CStore. When we went and evaluated it, I think we found the same performance issues that were there with those projects that everyone else had found. I think it's pretty well documented. However, we knew it was based on ZFS. We spent some time tuning it. We knew that we could get into the weeds of the kernel and start tweaking ZFS, but we knew that there was a ceiling of what performance we could get out of it. However, we did like that there were a lot of features, things like snapshotting and things that were out of the box with that. So then moving on to Mayastor, which potentially was a weird choice, given that when we evaluated it, it was still in beta. There weren't a huge number of features. I would probably say there aren't a huge number of features yet. Things like snapshotting, I know, are on the roadmap, and that there's a lot of stuff there. But on the flip side, Mayadata and DataCore were really, really helpful with showing what was on the roadmap. They really believed in our journey. They really were able to support that. And from a kind of partnership point of view, we felt we could really grow with Mayastor and the project. So that's why we went down it. And then, the technology of NVMe. I know that Longhorn are looking at putting that in now. So we feel like we've got kind of a year down the line with Mayastor already having that. And then I think here I mentioned RDMA, which is, again, a really, really cool bit of technology, which allows a remote machine to access the block devices on a compute node without having to go via the CPU of the remote compute node, which has some really, really interesting sort of performance implications and something that our hardware supports and that we can implement. So we felt that there was a lot more potential from the Mayastor project than some of the others there. I guess it's also worth saying we're a year on, we're a year down the line. So I think overall there's been a really smooth transition between Mayasdata and DataCore because there was an acquisition around the start of the year. There were some delays with that stable release, so I think it was due for November last year, but we only got it in January, February. However, saying that, to go from a beta to a V1 product, we're really, really happy with the stability. It's been really, really good. The performance has been as we've expected, and it's supported the scale that we've pushed at it. And we know that there are some features missing, like snapshots, but we've got confidence with DataCore that they can put that in there. And we know we get some access to their roadmap, so we know when it's coming, and it kind of fits our business goals as well. So kind of sum up what we've been saying. So it's really, really key to tailor how you evaluate something with your specific use case. A lot of what I have gone through and the decisions we have made is because of what Civo is. And if I was carrying this out for a different project that was, say, a web application running on a 20-node Kubernetes cluster inside a cloud provider, I'd probably come to some different conclusions. So make sure you know what your use case is. Are you running databases? Is it a web app? What's your read-write profile? And tailor your performance testing. And whether or not that partnership there, is that a requirement for you? Are you happy though getting what you know that you're getting? You'll get features as they come out, or are you expecting some hockey stick growth, as one of our managers say, and you need to find a partner that can support that. Performance is key, but again, don't get hung up on the numbers. When you get your performance profile for a database, you would realize that those max throughput numbers that tools like FIO push out, you probably won't be hitting day to day, and that you'll be running at 10-15% of the potential throughput. So if vendor A has a number of 500 and vendor B has a number of 450, but you prefer vendor B for everything else, go with vendor B even though it's got a lower number, because you probably won't hit it. If you've got a use case that is pushing that envelope though, then again, it changes. So make the right choice for the product you are developing. And the last thing in there is, if possible, design for change. It's something we built into Civo at the start, that any bit of the components in our product we can kind of swap out. We know that things change from a technology point of view. So, we're using whatever we're using for, say, virtual machine delivery at the moment. That project may die, or there may be something better that comes along. It's kind of the world of cloud native at the moment. There's a huge amount of change, new projects coming along. So if you can design your architecture to cover for that change, then do it up front, and then you'll make something like a storage migration project seem a lot less scary than it is. Few other things that to take away here. We've got a Civo, we've got an academy there which is completely free of YouTube videos, so please check that out. If you want to talk in person, I and a good number of the team will be at KubeCon North America, and we've just announced actually an event in February as well, Navigate, if you did want to come and meet us in person in Tampa and get some, at least for the Northern Hemisphere, or even the Southern Hemisphere, a little bit of summer sun if you're in Europe. Definitely looking forward to that. I guess, any other questions from the community?
This talk is something that's, I would say, somewhat of a recurring theme, that as much as there are, these technical aspects, the things that you mentioned about building a good partnership. And so in order to build a good partnership based on how my organization is, where we're at, the things that we find to be relevant or essential when it comes to these issues regarding storage, what kind of a partner are we going to need? What's our definition of contact, transparency, like you said, open source to avoid vendor lock-in? Having those priorities very clear from the get-go, and knowing what you're willing to negotiate on, and other points where maybe you can't be so flexible. I think those are really, really strong points that are put in there. So yeah, this was fantastic. If you can stop sharing your screen momentarily, I would like to be able to share mine. 1 second. And can we all go to Florida in February? That sounds fantastic.
Absolutely. I mean, definitely look forward. I am very slightly nervous though that the entirety of Civo are then going to go to Disney World, and we're just going to have no one actually working for the week afterwards. But we'll see. Oh, it's Disneyland, isn't it? Disneyland in Florida.
Yeah. Disney. No. Disneyland's West Coast. Disney World is East.
World is the other one. Yeah.
In Orlando. No, it's all good. Sorry, we did get a quick question. Are you already using NVMe TCP in production?
Yes, we are. We have been for the past, nearly a year now. We've been using it. We've not been using RDMA. It's on our roadmap to look at, but we've been using NVMe. If you launch a cluster in Civo today, it is backed by NVMe over TCP.
All right, good to know. Good. Kai says that he's not going to Disneyland or Disney World. Sorry, don't worry.
Okay, that's fine. I would say that what was I going to say with NVMe? I can't remember now.
Disney World.
Yeah, it's gone.
It is. NVMe. Which one would it be? Would it be both? I think you were saying something about both.
No, the thought has absolutely left my mind. So
that's okay. Kai, that one's on you.
It is on you, Kai.
If you've got questions, follow up with Kai in the Civo Slack. No, for real, this is an amazing talk. As usual, delivering high quality content. Really, really appreciate it. That being said, Dinesh, this is no surprise for you because you're a veteran in the Data on Kubernetes community. As always, we have our amazing artist, Angel, who's in the background drawing a artistic depiction of the things covered in the talk. So here we have, Dinesh making the decisions about which cloud native storage vendor he's going to be working with. the different criteria that was explained. Anyway, really, really liked it. You'll get the slides in our Slack as well as on our slide share account, so you can see all the links that were mentioned in the talk. And Dinesh, look forward to seeing you in KubeCon and the rest of you all on Slack, right?
Absolutely. Thank you.